again, we're going to ignore the printed notes. We're going to get to average value a different way than the notes say, and I think a way that makes more sense. At least it makes more sense to me. Okay, so I've got some function, and I want to know the average value from A to B. Like on the graph, do you know what I mean when I say average value? Like, what's another word for average value, do you think? Then we'll eyeball it. Average value means, like, graphically. Maybe if I ask you to sketch it in, I wonder if you'd sketch it in correctly. The average value is another word for the average height. So I'm kind of just eyeballing this. Somewhere between the max and the min is the average height of that function. This is my average height. However tall that is, that's my average height. Now, I'm going to use two colors. So if you got two colors, that's great. If you want to like cross hatch or whatever, I guess you could do that. My average height is drawn so that the red area that's a rectangle, so that's an easy one. The red area is going to equal the blue area, and the blue area is the area that's under the curve. Area equals area. The rectangular red area equals the blue area. Alright, how about a formula for the red area? That's the easy one. That's a rectangle. So length times height, base times height. What's the base of that red rectangle? B minus A. And the height of it we don't know, that's what we're trying to figure out. So I'm just going to say that's the average value. So B minus A times the average value. Right, that would be the red area. I don't know the average value, so I don't really know the red area right now. But I can figure out the blue area. How do I find the area under a curve? Under a curve, that's the integral from a to b of f of x dx. Yeah, the integral tells me the area. So I know this side, I know the blue area. Like if I know the function, I can take an integral from a to b, do the antiderivative, plug in top minus plug in bottom. Or just shove it in the calculator, let the calculator math 9 that thing and tell me what that is. If I know B and A, then I can solve for average value. In fact, let's just go ahead and put our conclusion down here in the box. The average value is basically the area divided by the width. But we usually put the width first, so 1 over B minus A times the integral from a to b of f of x dx. That's the big deal formula for today. So you either memorize that formula. I don't really memorize the formula. I almost always, like, for the first time I'm doing this every year, I think back to this picture, and the average height, here's how my brain thinks about it. The average height is the area divided by the width. that's an easier formula to remember. Like, you already know that area is width times height. Now if you just fill in some calculus things, you get 1 over b minus a, integral from a to b, f of x dx. That looks really fancy, but it's not really fancy. It's just area divided by the width. Tells you the average height. Okay, let's do some together. By the way, 1 through 5 are problems from yesterday, so we can skip past those. Let's jump to number 6. Find the average value of 3x squared minus 2x on the interval 1 to 4. Okay. So average value, I'm even going to start with my word equation because this is how I remember it. 1 over the width times the area. Okay, the width, I don't know if we should, I'm hesitant to sketch it. Like, sketching it helps me see what's going on, but I don't really want to sketch it because I don't know what that parabola looks like. So I don't know if this is a good idea or not, but from 1 to 4, I have no idea what the parabola is, so I probably shouldn't be sketching this thing. But it helps me think about how to find the average height. Also helps me see visually what's the width of that region. Picking on people here. Ryder, what's the width of that region? 3. And Evan, how do I find the area of that blue region? So when we want to find area, slope goes with derivative, area goes with antiderivative. So I want to do the antiderivative because that tells me area from 1 to 4 of that graph. This one doesn't say calculator, so I guess I have to do this one by hand. But before we get into the details of taking an antiderivative, are we okay with 1 over the width times the area? Okay, so now let's do some antiderivatives here. Laura, what's the antiderivative of 3x squared?
X cubed.
Good. It's nice when they give us easy ones to deal with. Isabel, what's the antiderivative of negative 2x? Negative x squared. And then I need to plug in 1 and 4. I'm going to leave the 1/3 just out front of everybody. And I'm going to have a big safe stop coming soon here. So if I plug in 4 cubed minus 4 squared. And then if I plug in 1, so plug in the top minus plug in the bottom. 1 cubed minus 1 squared. That's a safe stop. But it's a safe stop that we could clean up quite a bit. Because 1 minus 1 is 0. 64 minus 16 is 48. Divided by 3 is 16. So again, safe stop versus multiple choice answer. It's just algebra cleanup. Back up, big picture, to find the average value, 1 over the width times the area. Number 7, find the average value of this function on 0 to 3. Most of you are not going to be writing word equations every time, but I'm going to keep writing it because that's how my brain thinks about it, and then I can fill in the pieces after that. fact, why don't you see if you can finish that one off? Bottom. So 9 times 3 minus 27 over 3. If you recognize that plugging in 0 gives you 0, then you can just leave that part off. I'm very hesitant to do that because students start thinking, oh, I don't need to even plug in the bottom, I'll just plug in the top. So I'm going to show it, even though I can tell already that that's not really adding anything. Literally, it's adding nothing to the problem. So that would be okay as a safe stop. It's kind of a weird looking answer, but it's okay. I wanted to keep going. Let's see, 27 minus 9, all of that was 0. 18 over 3 is 6. Again, your safe stop versus your multiple choice answer. Yes, absolutely. Yep. So yeah, the question was if you really wanted to safe stop it and you just put 3 cubed there, definitely okay. You got to get to this pot where you do the substitution. So you have to plug in the 0 and the 3, but as soon as you plug in the 0 and the 3, you don't have to do anything else. So this is definitely not a safe stop right here. Because you haven't substituted. It's not calculator ready. There's more to do. Okay, 8 says use a calculator. On the interval 1 to 2, what is the average value? Okay, so the setup is the same. Average value is 1 over the width times the area. Again, most of you are not going to write that word problem, that word equation. You're just going to jump straight to the formula. But it helps me remember the formula if I know where it comes from. So 1 over, what's the width of this area? Just 1. The integral from 1 to 2. And this says I can use my calculator. I guess I could do this one by hand, but why bother if you get to use the calculator? What's the magic button that the calculator has for us? How do I get the antiderivative, the integral symbol to show up? Math 9. Math. Again, if all you remember is math, scroll down until you find it. Math 9. 1 to 2. Fraction bar, not really necessary if it's just 1 divided by x cubed. And the 1 over 1 out front obviously doesn't do anything, so 0.375, that's all it is. Speaking of showing your work to get full credit, I mean, I hope this is obvious, but you have to show this. Like, we know your calculator is doing the work, but you got to tell me what you're doing. You can't just say the answer is 0.375. You got to show me where that came from. I know the calculator did the work, but like, what did you tell the calculator to do? So show the setup. Number 9. Ooh, this looks. Find the value of k such that the average value of sine of x on 0 to k is 2 over pi. Alright, well, again, I'm going to back all the way up to average value is 1 over the width times the area. What makes this problem different than all the previous problems? We don't know the width. That's one thing. So what will I put for the width? 1 over k. The area. What will my limits for the area be? 0 to k of sine of x dx. And then what's definitely different is I know the answer. Like the average value is 2 over pi. Okay, it says calculator, but I don't know that the calculator is going to be much help initially, because the calculator can't do, right, I can't put a, I mean, I could put a k in there, I don't know what would happen, but my calculator doesn't know what k is, so don't, right, I mean, I could put k in there, but the calculator doesn't know k either, so don't do this. Like, your calculator does not know k. It would give you an answer, but I don't know what it would be. It wouldn't make sense. So I've got to do some of this by hand. So I need the antiderivative of sine. Cody, what's the antiderivative of sine? Good, negative cosine. Okay, so 2 over pi equals 1 over k. Negative cosine of k minus negative cosine of 0. Cosine of 0. Sailor knows what cosine of 0 is. Let's see, 0 degrees is right there. Or 0 radians, either one. So it's 1. Cosine of 0 is 1. Minus minus is plus sign. So 2 over pi, 1 over k. I'm going to switch those around and make that 1 minus cosine of k, just because that looks better. Trying to figure out what k is from that. I do have a calculator, so that means that's helpful. I'm going to let the calculator find this. There's a couple different algebra ways to do this. I'm going to move the 2 over pi over like this. And then just put all that in for y1. And then I'll be looking for a 0 of that thing. Because my calculator can find zeros. So y equals 1 over x. Go in fraction bar to make this look better. 1 over x. 1 minus cosine of x. Minus 2 over pi. Yeah, I don't think I have a chance of solving that by hand because the k is inside the cosine and outside the cosine. So I'm going to graph this thing and let my calculator find the 0. Okay, something in there. So I want to look closer at that. So I'm going to change my x window to be 0 to, I don't know, 1, 2, 3, 4, 5 maybe. And my y window definitely does not need to go to negative 10 and 10. I'm going to go negative 2 to 2. Just trying to see this thing better. Okay, oof, that's still pretty hard to see. How many zeros, how many answers are there? I think there's 2. So I could use Calc 0. I could zoom in a little bit more. Negative 1 to 1 even. Probably go smaller than that, but there we go. That's good enough to see them both. Okay, second Calc 0. Second Calc. Ooh, that's not what I wanted. Second Calc, there we go. And then it walks you through how to find the zeros. Have we done this before? Have you all done this before? Okay. So it walks you through. Left bound means get to the left of the 0. Press enter. Write down means get to the right of the 0. Press enter, and then you can just press enter again. So there's one of my answers. 1.571. That might be pi over 2. I don't know. Doesn't matter. Go find the other answer. Second calc 0. Left bound. Right bound. Guess. Oh, that's definitely pi. So 3.142. So apparently either one of those answers would work. That was definitely an algebra problem and a calculator problem more than a calculus problem, right? A little bit of calculus, a little bit of algebra, and definitely knowing how to make the calculator give you what you want.
Should we call it K1 and K2 or just K?
You could just say K. It probably would be better to say K1 and K2, but either way.
You have to have both answers just because I put my calculator in one answer from the very beginning.
Let's see. Let's check at the beginning. Find the value of K such that the average value. So it doesn't restrict where K should be, and there's 2 answers, so I would need to give both answers. When you say did your calculator like have a solver and it just gives one answer? So that's where the graph would be helpful because you could see that there's 2 answers. Because you're right, the calculators that will just solve anything, usually they only give you one answer. They don't know to look for another answer. So a graph would help you, point you in the right direction. Okay, today's assignment is still worksheet 3, but 7 through 14. So, back to worksheet 3. And I would say only use the calculator when it says use the calculator. So 7 and 8 will get you some practice on integration by hand, antiderivatives by hand. So try 7 and 8 right now, and I'll work them up here, and then we'll see if we get the same. Not even see, like you may not even know what the answer is, right? Because you save stop it and you're done. But if you keep going, you get 0 for an answer, which maybe seems weird. But if you look at the graph from 0 to 3, apparently that means this area is equal to this area over here. And so the average height between 0 and 3 is 0. So it's okay to have 0 as an answer. By the way, a little side note here, you can integrate on the graphing. Like, so Math 9 integrates, but you can also integrate here, second calc. Go down to integrate. Lower limit, you can just type in 0. Upper limit is 3. And this is kind of nice because it gives you the answer, but it also shades it, so it kind of reminds you that the integral tells you the area. And sure enough, that area is 0, so the average height is 0.
How would you do that?
So if you want to integrate on the graph, second calc, and then it's even the symbols there. So if you've got, you can Math 9 it on the main screen. But if you want to see a picture of what's going on, you can integrate on the graph screen, and that's kind of nice because, again, it reminds you that the integral is the area. Leave it as a safe stop. If it's a multiple choice question, obviously we're going to simplify until we get down to 13 over 6. Uh-oh, what did I do wrong? So I increase the power by 1 to get to 3 halves. I divide by 3 halves, which is the same thing as multiplying by 2/3.
You divide by 3?
You divide by the new exponent. Or I could think about taking a derivative. I would multiply by 3/2. That would cancel the 2/3, and it would go down to 1/2. Most of you are already on the back. So I'm playing catch up. Speaking of safe stops, reminder that sine of pi over 2 is calculator ready, and it's not calculus, so that is a safe stop. So on a free response question, if you get stuck and you're like, oh, sine of pi over 2, what? Just leave it. It's fine. Perfectly acceptable answer. Hopefully you know that the sine of pi over 2 is 1. And then once you make it past 10, 11 and 12 are calculators, so once you get it set up, oh wait, 12 is one of those backwards problems. You have to do some work on your own. 13 is pretty straightforward. $14 will be interesting if you get there, when you get there.